And let's say a person right here has what we're looking for 80% chance of winning at that game. Yes? Does that mean that your team will win the game? No, it does not. What the probability is trying to convey to you that if there was a long series, i.e., if they played, say, 20 games, your team will win 80% of those games. Yes? But it does not predict or tell you which of those games that it will win. Questions there. Right? You ever heard someone say, I flipped a coin 3 times and they were all heads? What does that tell us about the next coin that's going to flip? Does that mean the next one is going to be tails? No, it does not. Probability does not work that way. And which is one of the interesting things and most powerful things about probabilities is that it allows us to control something that's uncontrollable. Yes, I cannot tell you what will happen next, but I can tell you what will happen over the long run. Questions there? There are actually 3 kinds of probability. The first one is something called a theoretical probability. In this class, this is the main kind of probability we will encounter. In a theoretical probability, what we do is we take the situation, we analyze the situation, and we come up with a theory as to what the probability will be. All right? So, for example, if I have a dice with 6 sides, right? And I feel that that dice is fair. In other words, I analyze the dice. I feel it's a fair dice. I can say the chance of getting a 4 will be 1 out of 6. Yes? I can say that that's the theoretical probability. Yes? Now, let's say I made a mistake, for example. And so, wait, anybody ever used a weighted dice before? I have some in my office, but you shouldn't play dice with me. I have some in my office. Yes? And so I thought the probability of getting a 4 is 1 out of 6. But when I take that die and I start rolling that die, 6 out of 6. I roll again, 6 out of 6. I roll again, 1 out of 6. I roll again, 6 out of 6. I roll again, 6 out of 6. Yes? What that tells me right here is that my theoretical analysis of the problem was incorrect. That can always happen. All right? Questions there? So, what's the second kind of probability? Your second kind of probability is something that is called, where'd it go? Something that's called an empirical probability. An empirical probability, on the other hand, is one where you do the event over and over and over again until you have a long series of the events, and you use that to determine the probability of the event. Yes? So remember my weighted die? I kept rolling the die, rolling the die. Let's say I rolled the die 100 times, and then 90 out of those 100 times a 6 showed up. Yes? I can then create an empirical probability and say that there is a 90% chance of getting a 6 when I roll that die. Yes? Right? And that will be called an empirical probability. In other words, I went through the actual process of flipping or rolling the die over and over and over again. Questions there? A lot of times in the real world, when we have really complex setups that is difficult to analyze, we yield back onto an empirical probability. All right. And so we just say, let's just do it over and do it over and do it and record the results. And then that gives an idea of what should happen in the future. Yeah. For example, car accidents. Do you think it's possible to come up with a formula that will tell you how many car accidents you will have on a Sunday? It's very, very, very difficult, right? The country is huge. There are thousands of kinds of cars. There are thousands of different kinds of drivers, right? There are different ages that they're driving at different times of the day. It may be raining, it may not be raining, right? It's really difficult to come up with a theoretical probability, yeah? But if we're like Allstate or Progressive, right? That's all we track is people call us and say, hey, I had an accident. And guess what? We can just look at all the Sundays from now way back to say 1980, right? That's what 10,000 Sundays going back, and then we can just say, okay, how many accidents we have each day and take an average, and that can give us an average of how many car accidents that we will have. Questions there? The last kind of empirical probability, which we won't see much in this class right here, is a probability of intuition. Right? For example, you want to go to a party in the evening, and you know you have to ask your parents, and you say, you know what, I have a 0% chance of going to a party this evening. Yes? It's just based upon my intuition and my feelings, how I set that probability. Yes? It's actually the main reason why people shouldn't gamble. You guys know how to gamble properly, right? It's actually the main reason people shouldn't gamble because people almost always gamble off their intuition. I like this team. I've been watching this team for 2 weeks or 3 weeks or for the entire season. They got this. All they have to do is just pass the ball to X, Y, and Z player and they're gonna win, right? And so you feel in your mind you have a high probability of success. Yes? Yeah. That's not how. Do you know how professional gamblers do it? No, what they do is actually do a theoretical probability. They sit down and they analyze every aspect of the game. They look at the offensive line as a whole, and then they go and they check the offensive line against every single offensive line that they've come across, and then they pull out the ones that are similar to the one that they're going to face, and then they go to each of the skill positions and then look at who those guys are going to face and how they have done in the past against similar people, right? And so what they do is they do a long form analysis to come up with a theoretical probability of how many yards per game they're going to get, how good is the kicker, and all that kind of stuff. And then they come up a probability of a team winning or not. Yes? I guess what they can afford to do this because a lot of money is on the line. Yes? That's how they set the lines. They don't just say, 3.5 sounds good to me. Right? That's how we do it, right? Right? That's not how they do it at all. Right? And that's why almost always they win when it comes to those things right here. And in the year, they have hundreds and hundreds of thousands of dollars. And that's why they keep putting all them ads on TV. Say, hey, come play against us. You and your intuition against me and my analysis. Let's see who's going to win this one. Yes? Yes? And that's why you should never gamble in any scenario where you have not done a full analysis. Literally, if you're going to what do you call the place again when you gamble? Gambling institution. What do you call them again? If you're going to one of those places, you need to go with the understanding that you're not going to make money. Yes, you're going just to have fun. That's the reason why you're going. Yes, right? Because every single game that you're playing, they have done the analysis, and in the long run, you will not make money. Every single game is biased towards the house. Yes? Yeah, that's why you should open your own gambling institution and then be the house. The tell people come, give me your money, please. You have fun. You have fun. Give me your money. Yes, yes. Analysis is done in every single one of these games. Roulette, blackjack, then name the game. Everyone, you can pull up the analysis online, the theory, and they will show you that every single time the house is designed to win. Yes, obviously they can't predict what will happen next, and some people will win big. Yes, yes. But over the long run, the longer you play, the further and further you will fall behind. Questions there? So what's the lesson of my whole story? Either don't gamble or become a professional gambler. One of the two. Don't be in between that needed space of doing that last probability of it feels like or it looks like, or look, this team has won the last 5 games and they're on fire. Right? Right? You're just burning your money. Just burning your. Unless, of course, that's fun for you, burning money. No? Maybe? All right. I am paused. Questions here. So again, let's look at flipping a coin. In a theoretical probability, what will happen right here, you will investigate the coin. You look at the coin right here, it feels nice, well balanced. It has only 2 sides, a head and a tail, right? And so you can make that assumption. Out of the 2 possibilities, only one's going to be a head, so you can make the assumption it's going to be a 50-50 or 1 out of 2 chance of getting hits. Yes? You do that right here, that's called a theoretical probability. The empirical probability, on the other hand, is you will actually flip the coin 50,000 times. And you record how many times you get heads, right? And that number will be close. It won't be exactly 25,000 exactly. It'll be very, very close, 25,002, for example, in this example. Yes? And that, of course, will round to 0.5. Questions there? All right, cool. And that takes us to probability. The probability of an event is the proportion of times the event occurs in the long run. It describes the likelihood of the event occurring, not whether or not the event will occur. Okay? Excuse me. That's what I'm looking for right here. No, that's not the one I'm looking for. So there are basically two rules for probabilities. One, the probability of an event occurring must be between 0 and 1. Yes? Probability of a 0 means that the event will never occur, and the probability of 1 means that the event will always occur. Can anybody give me an example of something that has a probability of 0? Something that will never occur? Anybody? An event probability of 0. Say again? Fixed line? Well, actually, no. The way we are science is going these days, I don't think so. I'll say it's very low, but to say it's impossible in this day and age, no. Anybody else? Anybody else? Anybody else? Anybody else? The thing about these kind of events is that normally they have to be constructed because our world is so unique, right? That almost anything you can think of can actually occur. And so an example of something that's a probability of 0 is having a fair die, rolling the one die and getting a 10, right? That can never happen, right? Because of the construction of the die. It only has 6 spaces, right? I can't roll that die and get a 10. Yes? So, for example, you play a game and you need a 10 to win, right? That's your last roll and you need a 10 to win. The probability that you will win will be 0. Yes? Question there. A different probability right here is, let's say you're playing a game. I forget what it's called, like sorry or whatever. You're on the last spot and all you need is anything higher than a 1 or higher will allow you to win. Then the probability that you will win that game is 100%. Yeah? Because once you roll any number, will be enough to get you across the line. I think it's Baggerman. Yeah, any number you roll will get you across the line, and so therefore you have 100% chance of winning. Yeah, right. Watching a football game, the team has the ball. Less than 40 seconds, the other team doesn't have timeouts, and they take a knee. The probability that they will win is 100%. Yes, yes, because it's gonna let the clock run out. Game over. Questions there. In general, the probability of an event is the number of times that event happens divided by the total number of possible outcomes. Probability in that sense can be thought of as a relative frequency. It is the number of times divided by the total number of possible outcomes that event happens. The classic example is flipping a coin. You count how many times you get heads, divide by the number of times you flip the coin, and that gives the probability of getting hits. Questions there? Questions there? Cool, 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 cool. Now, the thing that guides all of this knowledge right here and all of this theory right here is something called the law of large numbers, or the LLM. It is one of the foundational theories of what's the word I'm looking for? Probability. The law of large numbers says that the theoretical probability and the empirical probability will become the same number if you let the experiment go long enough. If you let the experiment go 10,000, 20,000, 30,000 times, then the two numbers will align. And so what they're trying to say right here is you can predict the probability if you go ahead and analyze the situation carefully. Questions there? It is for the reason, for example, why if you have a coin, you can't just flip it 5 times and say, hey, heads showed up once, so the probability of heads is going to be 20%. Yes? You gotta flip it 50,000 times or 100,000 times, and after those 100,000 times, you look at the number of heads you get out of 100,000, and that will give you a much better approximation of what will happen. All right. This is how, for example, these fancy companies like Geico and them can do the prediction, because that's how they work, right? They have to be able to predict in a month how many car accidents they're going to have. Yes, that's what they do. They look back over their 30, 40, 50, 100 years of car accident data, and they use that data right here to predict how many they're going to have. Right? And so then they say, okay, so how many are going to have? I'm going to predict how much money I need to have, and then they set that money aside, and they pay that money out as the accidents come in. All right? Questions there. The key thing is they don't need to know the exact number. They just have to have a good estimate. Yeah? The better the estimate, the more profit they make, because everything left over is profit for themselves. Y'all know that's how insurance works, right? Y'all know how insurance works? What happens, insurance works, for example, on a monthly basis. Every single person who is insured, they get charged a small amount of money. And all that money is pulled together. And then those people who have claims, that money is drawn from the claim. If the insurance company did a good job, the amount they charge will be slightly higher than the amount that they have to pay out. And that slightly higher is the profit for that company. All right? Yes? No? Anywho, that's how it works right here. Again, law of large numbers says right here, as the sample size increases, the relative frequency right here will get closer, will line up with your theoretical probability. Notice right here, we're leaving the intuition probabilities out, because those literally, if I ask 5 people right here, what's the probability that the Patriots will win? Every single person will give me a different number, right? And most likely all those people will be wrong. Y'all are not betting on this game, are you? Oh, my bad. You guys got 2 weeks to do yourself some research. Yes. Yes, to do it properly. Yeah, but you have actually done properly. When you do it properly, it's a lot more fun to watch. Because you now know every single player and who they're going to be who's going to be guarding them. You're gonna know what kind of routes they're going to be running, which ones be more successful or not. And so you can literally predict what will happen next as the game is going. No? No, you just sit down there and just cheer and then get sad when something doesn't work. That they've been robbing people blind for how long now? No, I'm talking about football. The Super Bowl is in 2 weeks. The Patriots playing Seahawks. He's with the Patriots, so he's still alive. He's still hanging on. Questions there? No. So you're gonna be like the rest of the people, just giving them your money, huh? Just hand over your money. I digress. And the interesting thing, right, is if they pick exactly the right number, then they just make everything, right? If they pick exactly the right number, then both sets of people lose, and so they just take everything. That's just so unfair. Anyways, I digress. Probabilities can give us a meaning of what's likely to happen. A probability that's closer to 1 means something is more likely to happen. A probability that's closer to 0 means something that's less likely to happen. For example, the probability that someone will walk into this classroom with orange shoes is like what? 5%. And so what that means is that it's unlikely that someone will come in here with orange shoes. Does that guarantee that won't happen? No, someone might bet somebody that my team win, you gotta wear orange shoes to class just to make professor look weird, right? And it might happen, yeah. Right? But the probability that the next person coming in here is going to be small. The other question right here, the probability that someone will get an A on my test, one of you get an A, that probability is going to be really high. Yes? Someone in here is going to do well. Hopefully all of y'all. And so the probability that at least one of you guys gets an A, that's going to be really high. Questions there? Okay, the hope is all y'all get an A. Right? Nice, the nice shiny ones, the shiny one. Oh, that's a good point. I should mention that when preparing for this test, the test is given through WebAssign, yes? And so every question that's on the test will be a WebAssign question that you have done. So if you've been slacking and not doing your WebAssign questions, you're gonna get hit upside the head when you take this test, right? You cannot simply look at the notes and say, oh, we did these examples in class and do well. That's not how you do well on tests in this class. Okay, that's a bad idea. Okay, I have all my notes. I'm just going to sit here and say all my notes. That's not going to work. The WebAssign questions are very specific and they're often asked in a way that's kind of weird at the beginning, but after you practice them, they make sense to you. Yes? Yes? You've done them before, you notice that. And so you cannot make that mistake of, I'm just going to study, because that's how you did it at school or whatever. You study all the slides and you go back over your notes and say, you should suddenly do that, yes? But that will not be enough to prepare you for this test. Yeah, that's one of the big things that a lot of young students make. It's not that they didn't study, it's they just studied the wrong way or they studied the wrong thing, right? You have a whole bunch of knowledge, but it's just the wrong kind of knowledge, yes? And that can happen on this test. Questions there? Yeah, a lot of biology students, that's what happens to them on the first test. They study all the notes and all the stuff teacher did in class, and then when they look at the test, they get 50% right because what they were supposed to actually be studying is the textbook and the notes in the textbook, because that's where all the questions get pulled from. But All right, a probability experiment is an experiment where we describe an event that we then try out. All right, in this experiment right here, I am going to toss a fair coin 2 times in succession. The sample space is the set of all possible outcomes of that experiment. If you think about it for a second, if I have 2 coins and I flip them, there are only 4 things that can happen. Both coins are heads, both coins are tails, or again, this is distinct. The first is the head and the second is the tail, or the first is the tail and the second is the head. Yes? And so those are 4 possible outcomes. Again, note that these two right here are distinct. These are different outcomes. Questions there? The sample space is this list right here, the list of all possible outcomes. For example, if I ask you for the sample space of games you played in January, what would that sample space be? Anybody give me that sample space of the games they played in January? Anybody? Anybody? Did I choose the wrong random topic? Yes, games that you played. Any kind of games. I didn't put a. I played 2. You played 2 games. What are those 2 games? You mind saying? Silent Hill and Resident Evil 4. That's her samples. Anybody else give me their sample space for games they play in January? Which the 3 games are? Sims 4. Sims 4. Block Blast. Papa's Renderia. And Papa's Renderia. And so now, once we have those games, for example, we can then come up a probability that what's the next game she will play. Yes? We can then make up a probability of what the next game she will play. So I might ask you, how much time did you spend playing each game? Now I'm trying to create a theoretical probability, yes? Let's say the first game you played 2 hours and the other game you played 2 hours, then I can say the probability that you play this game is going to be 50%. Yes? Yeah? I can go ahead and create that probability once I know the sample space. And that's why we're talking about the sample space here, because the sample space is almost always the first step in making up your theoretical probability. You have to know what are the possible outcomes. All right? Questions there? If we wanted to dive deeper, we could ask, is the game a mobile game or a platform game? Yes, a game on your phone versus a game on a platform, yes? And we might slide the probability closer to the platform game because you got your phone on you right now, yes? And so we might say, well, it's a 5 out of 4 chance or 0.8 or 80% chance that you'll play the mobile game versus the 20% chance that you play the platform game, yes? Right? We can go a little bit deeper than if we want to, and we can ask them about their backgrounds, right? Maybe they've been playing games for the last 50 years, Maybe they've been playing games for the last 10 years and they have a understanding of when and how they play games. So they know, for example, they only play their platform games on the weekend, right? That's how I did it. Every Sunday night, I had to unplug my PlayStation 2, put it in the bottom drawer. That's how I did it. Because if not, I would stay up late every night playing PlayStation 2. I had a PlayStation 1. PlayStation 2. Yeah, I played Final Fantasy on the original PlayStation. We had to have 3 discs and no. Really? Really? Right, right. But if you know my experience right here, you'll know, for example, that I don't play on the weekend. Today is Wednesday. So the probability of the next game that I play most likely will be a mobile game, right? Right. I might be a 95% chance the next game I play will be a mobile game. Yes? Right? And the thing about the theoretical probability is just how deep you want to go, how much understanding based upon that sample space. Yeah? Questions there? Again, Super Bowl example, you have your football player wide receiver right here. You can look at how many drops he has and what situations he has those drops in, and then look at the defense that the team's playing right here and see what kind of defense they play against that kind of player. Yeah. And if they play a defense that he often drops the ball, then you can drop your probability of, there's prop bets, say, for example, does he get more than 50 yards receiving? Yes? You can drop that probability that will happen because that team will play him well. Yes? No? I'm trying to encourage you guys not to gamble. You don't want to do the hard work required. Anyways, I digress. All right, and so they have an example right here. Find the probability of getting exactly 2 heads. The probability of getting exactly 2 heads is the outcome. There's 1 right here out of a total out of a total possibility of 4. And so the theoretical probability of getting 2 heads is going to be 1 out of 4. Questions there? The way we'll do that empirically is we'll get 2 coins and flip them 100 times, 1,000 times, 2,000 times, 20,000 times, and then count how many times you get 2 heads out of the total number of times to flip the coin. Take a while, yes? Anyways, I digress. All right. This one I got hit the play button on. All right, so let's see if you guys can help me out right here. On the toss of a coin, what is the sample space for a toss of a coin? A regular coin that you have in your pocket, that you have in your bank account. What's the sample space for toss of a coin? Yes. Yes. Heads or tails. And so that's going to be our sample space right here. Heads or tails. Okay. With the roll of a die, what's the sample space for a roll of a die? 1, 2, 3, 4, 5, 6. Yes? Right. Questions there? So for example, if I ask you what's the probability that you roll a die and get 0, that's going to be 0. That will never happen. That is not in the sample space. Yeah? Selecting a university student from random, what's that sample space going to be? That is going to be the list of the names of every single student at the university. That's going to be the sample space, right? If I pick a person at random, a name is going to pop up. Each and every single name. So then, therefore, this is going to be a list of 1,000 names. Questions there? Should we stop here? I don't want to get too far ahead. Yeah. We're already 1 class ahead. We should be fine. Let's go ahead and stop right here. Any questions?